Hey guys, welcome to the video. As some of you might be aware, over the past few years I've been intermittently dabbling in health related affairs, and one thing that really used to grind my gears was having to count calories. At the best of times, fiddling around with quantities, converting units like kilojoules and calories, and dealing with weight and all of its complexities while trying to record this information into some kind of smartphone or under a pad, washing my hands every 3 seconds, it'd drive me crazy. So what I did was look into some solutions to see if I could find something that would help me with this problem, and I was underwhelmed with the things that I found. All I found was some cheap gimmicky items and nothing of any real substance that I thought would actually make this task any easier. And then I got that exciting feeling in the pit of my stomach, that feeling that you get when you like to make things and you come up with something that you think that maybe somebody hasn't solved yet that you might be able to solve. And that's when I came up with the calorie counter. Before I go into the technical details of how this thing works and lose most of you that find code about as exciting as watching somebody cook pancakes for 14 hours on repeat, perhaps we should just see what it does. This device is the calorie counter. It's the result of fusing a Raspberry Pi 3, the official Raspberry Pi screen, a HX711 load sensor amplifier, a load sensor, and 2 copper plates, along with a fistful of wires. The calorie counter is able to weigh and determine caloric content of foods with a high degree of accuracy. The data it keeps is entirely user-defined, which was a deliberate choice on my behalf because I don't like using public APIs like MyFitnessPal to get this kind of information, because the data can be dirty from people adding silly things to it and I can't be sure that they're accurate. There are 2 ways to use this. We can use it in all at once mode or one at a time mode. The idea behind this is if you're making something like a sandwich, this will reduce the required interactions with the device. So once an item's on the scales, you can just keep adding items, and every time you add a new item, it'll be teared off, ready for the next one. As you can see here, I'm just adding some bread and bananas to it, and now we've come across an item that is not in the database, a KFC coleslaw. There's a good reason for that not being in the database, but anyway. So we can go to add it like so, and we find when we look at the top that it is actually in kilojoules and not calories, so we can easily choose kilojoules and it'll automatically convert that to calories for us, and look at that, Bob's your uncle, we're away. In the second mode, one at a time, you can manually control the tare using the wireless keyboard. It's designed for when you're making a complex meal for many people. You can use Control-T to set the tare to whatever is currently on the sensor. You can then add any item you like, and you can use the keyboard to look up the item in the system and hit enter as you could before. When you're done, you know the caloric count of the food that you've created. At the end here, you can see I'm logging into the Fitbit API to allow the system to push to the Fitbit my meal for me. This is a work in progress. In the future, if I ever complete the unnecessary backlog of tasks that I assign myself, I may consider adding to this system what I call the pantry feature. Basically what it does is allow you to track your foods in portions. So for example, you make a cake and then you eat half of it, which is a reasonable thing to do. You might then go to your pantry and say, okay, you've eaten your first half, and then it records the last half and keeps it in the pantry, and then you can come back and then eat a portion of that portion, and it will keep tracking the amount of calories that you're consuming for you. And it's just sort of like a virtual reflection of what might be in your fridge, your freezer, or your cupboard, or your pantry. So that's what it is, and that's what it does. I'm sure there are some of you out there that are absolutely banging to know the technical details of what makes this thing tick. So fear not, I've got you. Here we go, let's take a look. So this is the repository all of this is based off by Tatabari. He's made this HX711 library for the Raspberry Pi. His is based off this code here by Underdog, but anyway, giving a bit of credit where it's due, I've got a link to this in the description. He basically has the code here to create an object that interfaces with my code and gets data and information from the HX711. So that's what this does. So this is the repository. You've got app here. This is where the entry point of the program is. I use Pygame because I wanted something versatile I could make my own interfaces with. I didn't want a generic type of interface. I wanted it to be completely full screen and customizable. In hindsight, it's probably a bit overkill, but it does the job pretty well. So I've used that in conjunction with that HX711 library we were looking at before, and also the Raspberry Pi GPIO library. So basically we come into this app, it initializes and opens the settings file. The settings file here has a resolution, it has whether it wants to be full screen or not. The reference unit is calculated like this. This is the instructions I followed from that repository. So you've got that information there. Then we've got the reference weight, which basically just tells my program what weight this reference unit represents. Weight precision just tells it, how many decimal places to have. In my case, I want 0 because grams are pretty precise as they are. JSON file name, this is just the name of where it keeps data for the food. So you've got the, fresh salmon is 208 calories per 100 grams. And yeah, we've got KFC coleslaw that we added in the example. So that's how it keeps track of that. This is basically the database for the entire thing. And then we've got debug true, which if enabled, I only just added this, it does this. It calls this monkey patch method that I just wrote, which basically loads in this current module here and replaces these modules in the Python system with these mock versions of the same thing, because obviously this HX711 and GPIO are only going to work on the Raspberry Pi. So this just doesn't do anything. It just lets the program run without throwing errors. So that does that, and then these will work. And then we do some initialization stuff. We get the HX711 ready. We set up our scenes, which we'll get to in a minute. And then, yeah, we've got a state machine that waits for a transition to be returned from the update call. And if, -1 represents no transition, but if it's not equal to that, then there is a transition, and it goes and gets that from the scene map. And we change scenes, and we get events, and we check for escapes, and we quit, etc. So that's a basic Pygame loop. I'm not going to go too much into that. You can look into Pygame if you want to understand how that works. Then if we go into scenes, or scene elements we'll start with, you can see here we've got some basic classes that represent more complex entities on the screen. So you've got text boxes, and you've got monitor boxes, input boxes, and scrollable selection boxes. They all go into what's called a scene, and here are the scenes. We've got the enum here, which is what we use to select the correct scene. And then you've got scenes, so a base class for scenes. You've got, which probably, now that I look at it with new eyes, this should be an abstract base class, but anyway, that's fine. And then you've got a test scene, main scene, scale scene. This is all of the scenes that you see in the thing. There's literally 3 of them, plus, actually, yeah, there's 3 of them, and then they have sub scenes in them as well. So that can be a little confusing, but it's all here. So you've got your boxes. I initialize all of those, and then in our update method, we go through and we update the values based. We get the information from the live weight, which is asynchronously gathered constantly. Somewhere I call this method, can't remember where. Here, so it's a separate thread that runs in the background. If it's not running, if it's not alive, then we start it up. And once we start it up, it just constantly sits there asking the HX711 what weight is on the sensor, and continuously updates that live weight value, which we can then use against the tear to figure out stuff and things. So all that worked really well. One other thing worth noting in here is the food logger file. This is a work in progress. I'm not going to go too much into it because it is a bit of a mess. I stole this OAuth class 2 server, OAuth 2 server data or class from another file, and then customized it to be able to log food. I made something inherit from it, and then added a few helper methods, and just made a method in here that gets an active Fitbit. So it tries to load from the Fitbit credentials.json, which isn't here because that's private data, but it basically has to have a client ID and a client secret in it. And once it runs, if it finds that, you know, it goes and while true, this is a bit dodgy. This basically just says while it doesn't work, just keep trying forever. So that's a problem there. That could be made better. But for now, that's all it does. It just basically authenticates with the Fitbit API and updates the credentials with what it ends up getting returned from the session. So it's a little bit convoluted. Like I said, this is a work in progress, but it does currently work. Just it's not great at the moment, but we'll get there on that one. So that's basically how this whole thing runs. If you have any questions or comments, please feel free to do that in the comments section. Love to hear about it. Maybe ways I could improve this. More than happy to answer and help with anything. If anyone out there is trying to do something similar and stuck on something, I had to solve a hell of a lot of problems myself to get this to work. So there you have it. That is the calorie counter that I made to solve this arduous problem that I was having. Let me know in the comments if you've got any suggestions or ideas on improvements, or if you want to see more things like this or more things about this, or in general, if you have anything you want to say to me, you know, I'd appreciate it if you would talk to me, because talking to me is fun. There'll be a link to the code in the description. Until we next meet, you know, have a good one, and I'll talk to you soon.